All right, so you're going to learn several different laws in chemistry, and remember from an earlier video that a law is just a statement. It's an observed behavior. It's not an explanation as to why something happens. It's simply just a statement or an observation. And you're going to learn a bunch of different laws this year, but there are three that we call fundamental chemical laws. So there's three fundamental laws that are followed in chemistry or that are observed in chemistry, and I'm going to talk about each of those in this video. So the first one, hopefully you remember, it's the law of conservation of mass. It says that no mass is created or destroyed in chemical reactions, and so that's the whole reason for balancing. The second fundamental law is the law of definite proportion. It's also called the law of constant composition, and that says that a given compound will always contain the same ratio masses of elements. So for example, water will always contain the same ratio. So there will always be 2 hydrogens to every 1 oxygen, or salt will always have 1 sodium to 1 chlorine. That's the law of definite proportions. Now, the last fundamental law is a little bit more difficult for some people to understand. It's called the law of multiple proportions, and what it says is that when 2 elements form a series of compounds, the ratios of the mass of the second element that combine with 1 gram of the first element is always a whole number. And so, for example, if you look at this compound right here, so you have compound A, B, and C, and each of those represents the mass, each of the numbers represents the mass of nitrogen that combines with 1 gram of oxygen. And so you have 1 gram of oxygen, and in compound A you have 1.75 grams of nitrogen. In compound B you have 0.875. And so if you look at these, they always form a whole ratio. And so if I am comparing the ratio of the amount of nitrogen in compound A versus B, so the ratio is 2. If I compare compound B to C, the ratio is 2. If I'm combining the ratio of A and C, that's 4. And so as long as you have 1 gram of one of the elements, the other elements are always going to have a whole number ratio. And so another example, let's just look at carbon and oxygen. So if I take carbon and oxygen, the 2 most common things I could combine them to form are carbon monoxide, and I could form carbon dioxide. Now in both of those, they each have 1 carbon, so that would be the equivalent of the 1 gram of oxygen over here, but the number of oxygens are different. So in carbon monoxide there's only 1, and in carbon dioxide there's 2. So if I figure out how many grams of oxygen you have, so let's just say your carbon is fixed at 1 gram. I'm going to use a little stoichiometry to figure out how many grams of oxygen you have in each. And so if I have 1 gram of the carbon, the formula weight would go on the bottom, and I'm trying to figure out how many grams of your oxygen you have. So if I do this cross multiplication, you get 1.33 grams. And if I then do the same thing over here for the CO2, so you have 1 gram of carbon, and I'm trying to figure out the grams of oxygen, so 16, but now I'm going to multiply that 16 by 2, because in CO2 you have 2 oxygens. Now if I do this cross multiplication, you get 2.66. So what the law of multiple proportions says that if you have this one element, carbon for example, fixed as 1 gram, in each of these 2 options the ratio of your oxygens is going to be a whole number. And so just to show you that, if I take the ratio of the oxygen in the second one versus the ratio of the oxygen in the first one, so 2.66 over 1.33, you get 2. So that's your whole number ratio. So the ratio of carbons is always 1 to 2. Now this would be the same if you were looking at nitrogen and oxygen, so you could be forming nitrogen monoxide, or I could be forming nitrogen dioxide. It doesn't matter, it's the same. As long as you keep one of your elements fixed at 1 gram, the ratio of the other elements is always going to be some small whole number. So that is the law of multiple proportions.